vector triple product. Let's say we have three vectors A, B and C. Now we know B cross C is perpendicular to both B and C. So let's say this is B and this is C. So this would be B cross C, perpendicular to both. Let's say this is A. Then A cross B cross C would be perpendicular to both vector A and vector B cross C. So that means, let's say this, remember, this is going to be perpendicular and this is going to be perpendicular. I am not very precise in my drawing. I am just drawing it to show how exactly might look like. So, which means that A cross B cross C lies on the plane of B and C. So that means this is, remember, A cross B cross C. So this will lie on this plane. Now, one very important equation is vector A cross vector B cross vector C is equal to vector A dot C B minus A dot B C. Now let's see how we can prove this. With this equation, we can simplify the calculation of vector triple product and convert this into dot products. Okay. So let's say we have ABC, three vectors. So vector A, B and C such that vector B is along J and vector C is in the plane of J and K, which means vector B is equal to B2J. Vector C can be written as C2J plus C3K. So here it means that the components along I and K are 0 and component along I is 0 in case of vector C. Now, vector A is A1I plus A2J plus A3K. This has all the three components. Let's look at LHS. A cross B cross C. Now A is A1I plus A2J plus A3K cross B. Vector B is B2J cross C2J plus C3K. A1I plus A2J plus A3K cross B2 C2 J square plus B2 C3 J cross K. J square is 0 in case of cross products. So A1I plus A2J plus A3K cross B2 C3 JK I. Remember, it is cyclic. So JK, J cross K is I. K cross J would be minus I. Okay. So now A1 B2 C3 I cross I plus A2 B2 C3 J cross I. Remember, you have to write it in that order itself because it is not commutative. Plus A3 B2 C3 K cross I. Okay, we don't really require this bracket. Now I cross I is 0. J cross I is minus K. So it will become minus A2 B2 C3 K. K cross I is plus J. So A3 B2 C3 J. So we write it as A3 B2 C3 J minus A2 B2 C3 K. Okay, we have arrived at LHS. Now let's look at RHS. A dot C B minus A dot B C. So let's see what A dot C is. A dot C is going to be A1I plus A2J plus A3K dot C2J plus C3K. A1 C2 IJ, remember this is dot product, plus A2 C2 I A2 C2 J square, or to be more explicit, let's say J, because we are talking of dot products, plus A3 C2 K dot J plus A2 C2 J dot J. Now A1 C3 I K plus A2 C3 J K plus A3 C3 K dot K. Now I cross J, I dot J 0, K dot J 0, I dot K is 0, J dot K is 0. So what we are left with, A2 C2, and this is 1, J dot J is 1, K dot K is 1, so plus A3 C3. Similarly, A dot B would be A1I plus A2J plus A3K dot B2J, which is equal to A1 B2 IJ plus A2 B2 J dot J plus A3 B2 K dot J. Here J dot J will be 0. Here I dot J would be 0. K dot J would be 0. So we are left with A2 B2. J dot J is 1. So A dot C dot B minus A dot B C is equal to A2 C2 plus A3 C3, and B2 is B is B2 J minus A dot B is A2 B2 and C is C2J plus C3K. A2 B2 C2 J plus A3 B2 C3 J minus A2 B2 C2 J minus A2 B2 C3 K. A2 B2 C2 J, A2 B2 C2 J is cancelled, and we are left with A3 B2 C3 J minus A2 B2 C3. Okay, now if we look at this, A3 B2 C3 J minus A2 B2 C3. So LHS equal to RHS. So hence we have proved that. Now another very important point is, let's say A cross B cross C, which is equal to minus C cross A cross B. Remember, it is not commutative. Vector triple product is not commutative. So if you reverse the order, it becomes a negative vector. Now minus C. Now this product, we can use the previously proved, apply that equation. So minus C B A minus C A B. Now just to remove this minus, now again we reverse the order of this. C A B minus C B A. Now important, just think about this a little bit and you will realize that A cross B cross C is equal to, or will be equal to, vector A cross B cross C. That means this would be possible only if C A B is equal to C B A in this, because then only this will become 0. Or in general, A B, given three vectors A B C, AB is equal to 0 and CB is equal to, C dot B is equal to 0. Now this would be possible only when B is perpendicular to both A and C. Remember the formula of the dot product. Only when the angle between them is 90 degree would the dot product be 0. Another interesting aspect is, if A is perpendicular to B and A is perpendicular to C, then A cross B cross C is going to be equal to a 0 vector. So this is vector triple product. In the next session, we will look at some applications of these vectors. That's it. Bye for now.